Welcome back again. Today we have a sequence and also we have a summation. We try to find the sequence and how's the element here. You saw the sequence before. We saw it before. We talked about convergence, divergence, but here we don't have such problem like a convergence or divergence. No, just finding the terms. Okay, look at here. At the beginning, you know the definition of the sequence is what? Yes, the definition of the sequence that we have. Sorry. Okay, now the sequence, the curves, the terms is very important. You know, if I have an, I'm going to give n 1, 2, 3, 4, and go on. So I'll get what? I'll get 1, 1 over 2, 1 over 3, 1 over 4. Is that clear? How to find the terms? That's it. So we have arithmetic or geometric progression of the geometric sequence. What do you mean by geometry? Of course, we should have arithmetic. Means that there's a rhythm between them. We have R. Okay, Kaka? We have R. So how we find them? You can see from the terms. If we have, for example, 1, 1 over 2, 1 over 4, 1 over 8, I think there is a rhythm between them. How we find it? You can divide first term by the second term. Of course, you will get the something. And you can divide third by the second term. You should get the same thing. And of course, the same. So in that case, I say I have a geometric sequence. It's not a series. It's a geometric sequence such that we have a rhythm between all elements that we have. And as well, we have what? We have, this is the general form. We have such sequence like a Bn, like a Cn, like a Dn. How we find the terms? For example, if I say find the 10th term, you know, we have for Bn, we have what? You can see we have, if I try to expand the sequence, I say if n is equal to 1, I will get, or if let n say n is equal to 0, because we start with a natural number, we say we will get 1, minus 1, 1, minus 1, after expanding, right? If you give the n, it will be minus, negative, positive, and go on. How about Cn? Can you expand Cn, Kaka? So we have 2 multiply 5n. So I'm going to find first 5n. I say Cn equal to 5n, for example. If n 0, I'll get 1. If n is 1, I'll get what? 5 square, right? 5 cube, and go on. But here we multiplied by 2, so it means that I'm going to multiply by 2. I'll get all this element by multiplying by 2. So I'll get 50, right? So it will be the 2, 10, 50, and go on. I think it's easy, right? So I'm going to leave D for you. 1 over 3, 1 over 3, 1 over 9, and go on. So here's the term, one by one. In your lecture note, mentioned how to get that one, mentioned how to get D by each element. Yes, Kaka. Here, no. This is not. This is the series. Later we are going to do. This is the just tell you that this sequence has got rhythm. That's it. But that one, of course, this is not a rhythm. We multiply by something. Generally speaking, we can use something is called recursion. Let me just find for you. We have a Sn and Tn. Then sometimes we say Sn plus Tn. So how we do like that? It's easy. First, try to find the term of Sn, expand it. So give me the clue or give me the number of Sn. How's the term of the Sn? N should be 0, so I'll get minus 1, right? Minus 1, 3. If n is 1, I will get minus 1 plus 4, so I'll get 3, right? Then 8 minus 1, 7, and something like that. Am I right? How about Tn? Of course, 7 and 4, right? 7 minus 3 is 4, and Later I'll get what? 1 and minus 2. So if I say Sn plus Tn, how we do it? We are going to do one by one, term by term. So I say minus 1 plus 7 will be 6. 3, 4, 7, 8, 9, and go on. Easy. You know how to deal with the addition of between two sequences, Kaka? Good. Bash. Now we have recurrence or recurrence relation. What do you mean by that one? How we find them? We have this term. Look at the example to understand what do you mean by recurrence relation. We have a relation, equation, terms, one or more, previous term, means that each term depends on the previous one. Maybe by depending, we mean by one time depending or two terms depending. Maybe I say A2 depend on the A0 and A1. Or maybe I say A1 depends on A0. And it's called initial, of course. And sometimes we are going to find the solution. All these concepts that I taught, now I'm going to answer one by one to give you the idea one by one by the examples, okay? So look at here. We have AN is a sequence, satisfy this relation. AN is the sphere. Okay, N start from what? Look. N start from what? 1, 2, 3. And I have an initial point, A0. So find A1, A2, A3. So how's that one? So this is called recurrence or recursion sometimes. Recurrence, what do you mean? Means that depending on the other steps. Okay, dears? Hello? Good. So how? Here we are. I have I should start with what? With 1. I have A1. I see equal to A1 minus 1 is equal to what? 0. A0 plus 3. So because A0 is given initial, I can find A1. So A1 is equal to what? 5. So tell me about A2. A2 equal to A1 plus 3. So I'll get what? 8. And that's it. So this is each term depends on the previous one. A0. A2 depends on A1. A1 to A0. Like that. Understood? Easy? You can, for example, if I say find A10, you should find A9, then put it plus 3. Good. Sometimes we have two terms depend. What do you mean? Look at this example. We have AN equal to AN minus 1, AN plus minus 2. Right? AN minus 1, AN minus 2. And N start from 2. So it should be, I should have at least 2 values, right? Because I'm starting with A0 and A1, then I'm starting with A2. So that's why you can see from here you have A0 and A1. Am I right? Clear? Okay. So tell me about A2 equal to what in this example, example number 6. A2 equal to what? I say depending on this equation, this given, depending on here. Okay. I can write A0 equal to A1 minus A2, A0. Am I right? Hello? Understanding? Good. So A0 is what? 3, 5. So I say equal to 5 minus 3 is equal to 2. Am I right? Okay, tell me about A3 equal to what? Yalla. A3 equal to what? They is equal to A2 minus A1. So A2 it was 2, A1 it was 5. Am I right? Then I will get what? Minus 3. And go on. Question? Clear? Okay, Charlie to HD. Any question? Jamaat? Good. Now, that's how we find the elements each by one, A4, A5, and go on. Now, what do you mean by initial condition? Initial condition is like here is like A0 and A1. What do you mean by initial condition in that example? Like A0 equal to 2. The given is called initial. You got it, dear? Now we are going to talk about Fibonacci sequence, which has got many applications. Okay. Everywhere, you're right. It's everywhere actually. In the golden ratio, in the, I don't know, in the music, the piano, anything that you want. Has got many applications. How's the definition? We have a two initial value, 0 and 1. Then we are going to find F2 by what? By F2 equal to F1 plus F0. F3 equal to F2 plus F1 and go on. How? The first term is what? Is 0. So F2 is equal to what? 0 plus 1? 1. Okay. How about F3 is equal to 1 plus 1 equal to 2. Now, you can find at the beginning you have a 0, then we have 1. Add these 1, 2, I will get what? 1. Okay. Add these 2, I will get what? 2. This one, 3, 5, 8, and go on. So this is called Fibonacci sequence. It's very important, and we have, as I told you, many applications of it. You can see 1, 2, 3, 4, 5, and go on. Do you have any question about it? Good. And you saw the factorial, of course, because you graduated Cal 2, so it means that all of you saw the, right? Factorial is easy. For example, if I have a 4 factorial, I say is equal to what? 4, 3, 2, 1. If I have n factorial, I have what? I have n itself, n minus 1, n minus 2, right? Each time, we are going to decrease it by minus 1. Then till I will get 1. That's the definition of the factorial. Okay. Now, example 9 is a little bit tricky. And look at it. We have a formula at the beginning. an equal to 2an minus 1, an plus 1. Let me write that one. An equal to 2an minus 1 minus an minus 2. It was like that, right? Now, he say what? He say determine whether this sequence is a solution for the recurrence relation or not. So I will give you something. I say, tell me, this things, this an can be a solution for that formula or not. So what was the given? An equal to 3n. Am I right? Tamam? So now we are going to test. We are going to test this given is a solution or for here or not. That's the important. Good. Now how we solve that one? I know, I say, if an, for example, n to be any numbers, if an equal to 3n, so I can, let me that one is an equation, I can write down an depending on the given. Depending on this given, I can write down an minus 1 like what? 3n minus 1. Am I right? Yes. Tamam. How about depending on the given? An minus 2 equal to what? 3n minus 2. Okay? So I'm going to substitute these value. So I say an, look, I say an equal to 2an minus 1 minus an minus 2. You know why I changed the color? To understand, I'm starting. I have a left side. This is the given. I'm going to start with the right side after using the given to get 3n. How? Look at here. I say 2n equal to what? We say is equal to 2 minus this package, right? 2, 3n minus 1. Am I right? Yeah. 3n minus 2. You are right. Tamam? Just put it in this place. So I'll get what? Let me check. We will get our 3n 3. So I'll get 6n minus 6 minus 3n plus 6. Am I right? After multiplication, dears. Then minus 6 with 6 and 6n 3n. I got what? Did I get the an that we wait for it? Yes. So this is mean that an, which is equal to 3n, is a solution for what? For an 2, an minus 1, an minus 2. That's mean that. So you have the given is give you try to make it the change that we needed, for example, minus 1, minus 2, then we put it in the equation. If it's equal to the original one, means that's a solution. Otherwise, no. Clear, dears? Tamam? Yalla. Now is your turn. Look. This is the equation, right? Equation star. We called as a star. So tell me, 2 to power n is tamam or not? Tell me, an equal to 2 power n is a solution or not? Yalla, do it. Okay. Now let me repeat it. Let me repeat it for you. We forgot recording, now you start recording. Look again. Look at me. We are going to use the previous method to show is solution or not. You know, we need to find the formula that we have, include the equation star. The given is what? A to power 2n. This is the given. Now, a to power n minus 1 equal to 2n minus 1. Am I right? And an minus 2 equal to what? 2n minus 2. So now I am putting in equation star. So I will get what? Forget about left side. Just focus on the right side. I will get what? 2 minus, am I right? What's equal to 2 minus n minus 2. And what? How was the left side? How was the shape? 2 to power n, right? And you know, these two equations, right and left, are not equal. Okay? They are not equal. So when they are not equal, you cannot show me generally. You should bring one example. It's called what? Counter example. Thank you. Now I say let's n be 2, right? So right hand side of the equation is what? Is 2 minus n minus 2. If I put 2, I will get what? 2 minus 2 power 0, right? I think something wrong. Just
n minus 2 n minus 1 minus
2 power n is equal to what?
the equation is 2 power n minus 2 power n.
You are right. here's the mistake, right? We have 2 to power n. تمام? So I'll get what if n in 2 is equal to 2 power 2 minus 2 power 0, which is equal to 3. How about left hand side of the equation? It was what? an equal to 2 power n. So when n is 2, I'll get what? 2 to power 2 is equal to 4. So it means that 4 and 3, which they are not equal. So when they are not equal, we can translate this information to what? To say that an equal to 2 to power n is not a solution for equation star.
Stefano, tu spiegala come ricordo. 2 power n minus 3 power
يعني تذكاري كام يعني هذه given aga
an minus 1.
yeah
2 power n.
أخرج أما given. Can you change that one? أي
Power reduce nothing.
here إيه
Except an minus 2 over 2 to 1 n minus 2.
right
The 2 power n is an n minus 2.
yes why not you can yes why not yes nada the same تحقیق رو قد جو the same okay kaka put it down just put it down so nothing understood kaka tamam good. Now again we have what? Kindly at home try to use an equal to 5 and put it in equation star and show me the solution or not. Let that one be homework. Clear? Good. And you can find the solution of course here, but do it at home. Now, if you remember in the example 5, what was example 5? Let me go bring to the example 5 again. Example 5, yes, we have what? an n minus 1 plus 3 and 8 naught is 2. Let me write from here. Let's see. An equal to yes an minus 1 plus 3 a naught it was 2. Do you remember that? Good. Now kindly answer the following. Find the formula, find the closed formula, means that show me the formula for nth term. I'll give you 2 terms, 3 terms, or sorry, I'm going to give you initial. Listen carefully. You have an initial, which a not equal to 2, and you have a formula an equal to an minus 1 plus 3. I say find the formula. We have 2 we can follow. We can follow 2 methods. We can follow 2 methods, 2 things to get the answer. How? We can start from the beginning to the end, which is called induction. 1, 2, 3, and to n. Or we can start from the n minus 1, n minus till a naught a1 is called deduction. Induction and deduction. Okay. Now I'm going to use the induction first. We say that if a1 equal to a1, it will be what? A naught is equal to 2. A1 will give me 2. A2 equal to what? 2 plus 3, right? We say equal to previous one plus 3. So if I have a 2, I say it's equal to 2 plus 3. How about next? Just listen. A naught equal to 2. A1 equal to A naught plus 3. So I'll get what? 5. Clear? And A2 equal to what? Is equal to A1 plus 3. And I can write down like that. A0 plus 3 plus 3. Am I right? Why? Because I am using the previous one. How about A3? Yalla. A2 plus 3. A2 can be written, am I right? And can be written exactly. Plus 3 plus 3. When somebody talk to me means that he's aware. So kindly repeat it. Now we can find the formula. How? We can say is equal to 2 plus 3 by 1. How about here? How about here? We can say is equal to what? 2 plus 3 multiplied 2. Am I right? Check it. 3 by 1, 3. 3 by 2, 6. How about here? 2 plus 3. How many 3 do we have? 3. So, like that, we can go with the steps. You can see from here, A2 equal to 3 by 1, A3 equal to 3 by 2, A4 equal to 3 by 3, and AN equal to what? A0 plus 3n times minus 1. Yes. لكوا. Which one? احنا general no. Exactly. Look, I'm going to find general. Just look at me. Okay, we are going to find general. Look. Amazon A1 plus 3. تمام. كما A2 أكاتا A0 plus 3 multiplied 2. دقتي يا ربا. Here's 3, here is 2. Am I right? أشما A4 ليرا چیم دسكي A0 plus 3 multiply 3. أما 3 هو چنا؟ هو 4. Clear? باش. أي ده چنا كي زانه؟ أي 10. 2 multiply 3 by 9. You got it? أي n چنا؟ 2 plus 3 multiply n minus 1. n هر چنيكا. n 100. I can say 99. Clear? One by one step by step, I will get the reason. Or this is induction. 1, 2, 3. Or from deduction. This is general formula, right? So I'm going to use 1 after an minus 1. An minus 1 will be what? An minus 2, right? So I'm going to expand that one. Yalla. Use the formula star. Use this formula. And give me an minus 2. You say what? Or an minus 1. If you use the star. You see is equal to an minus 2 plus 3. Am I right? دايما دانك دو يخوي. وايا كاكا. How about A2? A2 equal to A3 plus 3. A3 كتريش معناها بولانا. كاتبة multiplication. The same. You will get the same. Clear? جماعة? And like that. Then I will get what? I'll get last one. I will get 2, 3n minus 3. Again the same شيء. بهمان شيء حتى إردين. So I'll get the same. Clear, dears? That's called induction or deduction, and that's called finding the closed formula. We have actually during the exam or the quiz, you should think about step by step, all of them. Okay? How do induction حالية آسان تريش? Up to you. هذا كي I'm applying iteration. Iteration is what in mathematics? 1, 2, 3 is called iteration. F prime, F double prime, F double 3 derivative 4. How's iteration now? If the power increases. So an plus 1, an plus 2. Am I not seeing? All of this is called iteration. Okay. Look at this example to understand why we use the iteration, why we use this method, why just n plus 1. In the real life, you can find some example like that. You have what? Deposit 10,000 in a saving account bank, so you have a 10,000, and you are getting the benefit, the extra money, by which percent? 11 per year. Each year, if you put your money in the bank, each year your money will be 11% increase it. Okay, the bank will give you the refund. They will give you the benefits. So with the interest compound, interest distributor, okay, how much will be account after 3 years? 13 years, 3 years, 5 years, right? So you are going to increase each year. For example, during the exam, say show it by increasing. Of course, if you want to solve it, Pn is the problem that we have, and the P naught is the given. That's a P naught, right? The initial value that we have. Then we are increasing each year by by 11%. So I have in general, if I ask you P second year, I say is equal to what? Yeah, I say first year we say is equal to previous year, right? Plus 0. You can say yes, 11%, as you say, 0.11, and multiply P naught that we have, right? We have a value original, then benefit. How about P2? P1 plus the same, 0. P naught. Am I right?
Wait, what I divide the P naught?
By P1. Right? Understood? Then go on.
Right.
That one? Because we say 11% of the amount that you have. We have, for example, 500, now an interest of the 500. So we add them. Clear, dears? So you get what? You get this formula. Look at here, and go on. I know after what? P naught, Pn, that one. I'll get this one. Then we start with that value and go to the P naught. After 30 years, you can say after 30 years, I'll get what? 1.11 by what? By P naught. To an n by P naught. Understood? Why 11.1? 1.11 by 2 power n, 2 power 30. Why? Can you imagine why? Yeah. So because I look at the P2 equal to P1, 0.11, right? Multiply what? P1 again is equal to what? This formula, right? So let me do it for you again to be more clear. At the beginning, we don't count P1 actually. We just do it because I know P2 equal to P1 plus 11 P1. But P1 is not working. And if I ask you 13 times, 29 times, you need to resubstitute these values to each other. Finding the first line, finding the second line, find the third line till 13, which is not actually applicable, right? It's not a functional. We cannot find these all numbers together. So how we find them? I say P naught is a common, and I will get what? 1 plus 11%, right? Was equal to P naught 1 plus 0.11 was equal to what? 1.11 P naught or P naught. Multiply that one, right? So the rate of the interest is what? 1.11 per the first year. So if you ask me about P1, look, I can say is equal to P1 111, right? Am I right for P2? Okay, P1 it was equal to what? ده يا جماعة P1 equal to what? So 1.11 P naught, and we have what? 1.11 again. So I'll get what?
1.11.
Right? P2 equal to 1.11 square P naught. So depending on this induction, N1, N2, I can find what? P13 equal to 1.1113 P naught. How much the P naught? Whatever you like. 10,000? I don't know. It depends on the given. Did you understand? What did I do? Using the initial value to getting the nth formula to counting something. That's called recurve or recurrence and induction. I think okay. I'm going to just show you something here to remember that we have n squared term should be like that, and for fn is the Fibonacci 2 to power n 3 to power n factorial is familiar for you. And kindly, I'm going to leave, now this example is very, very easy, there's nothing, just you put the numbers, but I'm going to leave this example as a homework and is important. Kindly do it at home. Okay, dears? These are homework. Just read it, you will understand. Just read 5 minutes. That's enough for today. We stop here. Next lecture, because we have a quiz, next lecture we are going to finish.